Okay, in section 9.3, we're solving cube roots. If you remember from 9.1, we learned about square roots. So 9.1, we learned about square roots. 9.2, Pythagorean theorem. 9.3, cube roots. So a lot of what you see today is going to be really familiar to you. Okay, because a lot of the processes are still the same as when I was doing square roots. It's just cube roots now. All right, so you don't necessarily have to write down the words part of this, but I want you to write down what I'm about to write. Okay, so in 9.1, you learned that squaring a number was the inverse. Squaring a number and finding the square root undo each other. Basically, they're inverses. All right, so this is what it looked like. That 3 squared equals what? 3 squared equals what? 9. And the square root of 9 is the inverse. And that equals 3. All right, so we're showing that we can square a number and get a product, get the answer. And that answer, when I take the square root, it's the original number. All right, so they kind of undo each other. So guess what's going to happen today? Today, I can take the cube of a number. So cube means how many in the exponent when I cube it? 3, okay? So now let's say I take 3 to the third power. Well, 3 to the third power is the same as what? 3 times 3 times 3, right? You guys agree that's the same thing? What's 3 times 3 times 3? 27. So here's what it's saying. Well, if 3 to the third power is 27, then the cubed root is the inverse. And the cubed root of 27, guess what? Is, anybody want to take a wild guess? 3. Okay, so they're inverses. All right, so we're just showing that cubing a number and getting a product, getting an answer, when I take the cubed root of that answer, now I get the original number. All right, moving on to example 1. All right, go ahead and write down these 3 problems. Honestly, guys, I wrote them vertically, but you can even write them one next to the other. You don't really need a whole lot of space next to each one. We're going to work underneath them. Really either way, or you could work to the side. Either one. We're going to find a cubed root. Actually, I take that back. Just write them vertical. It really doesn't matter. Either way is fine. All right, so at number 1, you see the cubed root of 8. Right? Everybody see that? The cubed root of 8. So what does that mean? That means that, okay, this number right here means I have to multiply some number by itself 3 times to equal the number underneath the cubed root symbol, okay? So what number could I multiply by itself 3 times? Well, I know it's not 1. 1 times 1 times 1, and it's not 8. Any number I can multiply by itself? A couple people know. Anybody else? Shikari? Not 4. 4 times 4 times 4 is not 8. Faith? 2. All right, so here's what I'm going to say. All right, here's what I'm going to say. Here's my kind of proof behind why my answer is going to be 2. Because, so you write the word because, 2 to the third power, meaning 2 times 2 times 2, is 8. Everybody agree? 2 times 2 times 2 is 8. Then the cubed root of 8 has to be 2. All right? So because 2 to the third power is 8, and 8's the number that's underneath this radical, that means that the inverse is true. The cubed root of 8 is 2. All right? And hopefully when we do a couple more, that'll start kind of sinking in a little bit more. All right? Just go ahead and just try to follow along. Okay, so what do you notice that's a little different about the next one? It's got a negative, okay? So that just means that the cubed root of that number has to be negative. All right? Well, we actually just talked about this. The cubed root of 27 What number can be multiplied by itself 3 times, though, to equal negative 27? What do you think? Someone raise your hand and tell me. What number? Everybody should be raising their hand right now because we just said it, right? Okay, come on. Sam? Negative 3. So I'm going to say, because negative 3 raised to the third power equals negative 27, this is also true. That the cubed root of negative 27 is negative 3. Okay? So that's my why. All right? If negative 3 to the third power is negative 27, then the cubed root of negative 27 has to be negative 3. It can't be any other number. The last one's a fraction, but we can split it, okay? Meaning that I need to take the cubed root of the numerator and denominator. So I'm looking for a number that can be multiplied by itself 3 times to equal the value in my numerator and my denominator. Okay, so I'm looking for a because. Because what numbers can be raised to the third power to equal my numerator and denominator? I want you to write it down. Just try to write it down. Okay, if you're not sure, just leave it blank here for a minute. All right, what number can I multiply by itself? Because the 3 is here, it needs to be 3 times to equal that number. Bailey, what's going to be my top number? Yeah, you do. What can be multiplied by itself 3 times to equal 1? Ashley? 1. 1 times 1 times 1 is 1. Okay, so 1's my numerator. Okay. What number can be multiplied by itself 3 times to be 64? Well, I know it's not 2. That was 8. I know it's not 3. That was 27. It's 4. 4 times 4 is 16. And then 16 times 4 is 64. So it's 1/4. So because 1/4 to the third power is 1 over 64, then the cubed root of 1 over 64 has to be 1/4. Because that's what's being multiplied by itself 3 times to equal that number. All right, are you understanding some of the why behind it? Just simply saying, oh, cubed root, that doesn't mean a whole lot unless you understand what's happening there. The cubed root is some number multiplied by itself 3 times to equal that number. Are we there? Do you get that? Do we need to do more of these? Not as punishment, okay, but you really, really need to understand that. All right, so we're going to use this knowledge of taking the cubed root, and now we're going to apply it to expressions. All right, expressions mean that there's some kind of operation, addition, subtraction, multiplication, or division. Okay, so now we're taking cubed root, but that's not my answer. Now I'm going to do some other operation with another number to get to my answer. All right, go ahead and write down these 2 problems. Okay, so here's the challenge, guys. All right, for these 2 expressions, you could put the entire expression in your calculator, 1 line, hit the equal sign, and get your answer. How much thinking did you do on your own? None. Let's just be honest, right? So that's the problem that we had in Chapter 8, was if you were able to use your calculators, raising numbers to powers, you would just do. You wouldn't have to do any work at all. It would do all the thinking for you. So there's a compromise here, okay? Because we are using calculators, all right? We are using calculators. We can show 1 step in between to show that we didn't just tell our calculator to tell us the answer, and here's what it is. All right, these cubed roots are going to start getting really big. You see negative 216, they start getting a little bigger. So what we can do is we can use our calculator to take the cube root of that number. All right, so go ahead and open up your calculators. Go ahead and open them up. You're going to hit Shift and the square root button. You're going to see in like little yellow letters the cubed root. You see that kind of like in the background? You see that? Shift, cubed root. Don't forget your negative. Don't forget your negative. And then hit equals. What's the cubed root of negative 216? Negative 6. So here's what I need you to show me, okay? I need you to show me that you understand what operation is between the 2 and the square root. Not that your calculator told you that, but that you understand. So what operation is there? Addition, subtraction, multiplication, or division? Multiplication. So show me that. 2 times, what did you say? The cube root of negative 216? 2 times negative 6 is negative, 2 times negative 6 is negative 12. And for that part, you should not need your calculator. We can do that. So I do not want you to become so overly dependent on your calculators that you're punching this into your calculator. You should not need it for that. And that's not a good sign if you're using it for that. Okay? 2 times negative 6, you should just spit it out, negative 12. All right? And that's going to be your answer. Now, this step, you will lose points on your homework, your quiz, and your test if you don't have it. Because if you don't have that step, I'm going to think you put the entire thing in your calculator and it spit out the answer. And you didn't do any math on your own. All right? So use it to do the hard part, taking the cubed root, but then show me what operation is happening after that. Does that make sense, guys? All right, I hope that makes sense. You need at least one step there. All right, look at the next problem. Look at the next problem. The cube root of 125 raised to the 3rd power. All right, there is something that's happening here. Actually, it happened in our square root lesson too. What do you think is going to happen to these operations if I'm cubing the cubed root of any number? What's happening here, Milani?
It's going to change back to the original numbers.
Yeah, they cancel out. Cubing the cubed root of any number cancels out. So how could you show me that, though? Because, again, I'm going to be pretty strict on you showing me that you didn't just punch it in your calculator. How could you show me that you know that they're canceling out and it's just that number, Sam? Yeah, how could you show me that? There's just something real simple that I would want you to show me, that you know they're canceling out. Faith? No, all you have to do is just put an X through it, okay? By putting an X through it, guys, you're showing me, hey, I know that they're inverses and they're canceling each other out. And then you would just say 125. But those little X's through it, that shows me you understand they're inverses, okay? If you don't write the X's through it, you just punched it in your calculator. Do you see the difference? Okay? However, all right, let's say that you forgot the rule. You can't remember the rule. All right, there's another way that you could show work in an acceptable way. What is, you could put it in your calculator, what is the cubed root of 125? Nolan? It is 5. So you could also say 5 to the power of 3, which is 125. Okay, so you could say it either way. You guys following along? Okay, cubed roots, cubing. All right, so there's a couple ways you could show your work when you have inverses there. All right, questions. You see, guys, I have work there. Without any work, if all you do is write an answer, you're going to lose points. Okay, so you've got to show me a step there. All right, let's do 2 more. Obviously, these are getting to be, a few more operations, but that's okay. All right, we're just going to take it a step at a time and work through them. Go ahead and write down these 2 problems. Written down, not solved. Okay, I'm going to solve them with you. All right. What do you think you're going to do first on the first one? Just guessing. Just guessing. What do you think? Looking at it, you think I can do 18 minus 4 first? Nope. Leah, what do you think? What am I going to do first? The what of 8? What do I call that again? Not square root. Cubed root. Very good. Okay, the cubed root of 8 is what? Haley, what's the cubed root of 8 again? We know that one. We have it memorized. What's the cubed root of 8? 2. Very good. Okay, so 18 minus 4. Now that I've taken the cube root of 8, is that going to be 42? Ashlyn, am I just going to put those numbers together and make it 42? What do you think? What operation is happening between the 4 and the cubed root of 8? Is that... All right, so we're going to solve the second one on our own. So what do we see here that can make this really easy? I don't even need my calculator, nothing. What do we see here? I saw them on your paper. Someone raise your hand and tell me. Faith? Cancel out. And what do I do to show that I know it cancels? What do I write on there? Little x's. Little x's show me when I'm grading your paper that you understand those cancel out. And guys, now you just bring down the negative 64. Negative 64 plus 43 equals what? Negative 21. Okay? Negative 21. Now, if you didn't catch that, the second way you could have written that, if you didn't catch the little x's, is you could have said negative 4 to the third power plus 43, which is negative 64 plus 43, which still equals negative 21. All right, that's the other way that would have been okay. Okay? All right, that's example 2. And now example 3, and we'll be done. All right, go ahead and write down these 2 problems. We're doing 4 of these total. So it's this slide, the next slide, and then we're done. All right, so guys, this should look pretty familiar to you, okay? Except now, instead of it being x squared like it was the other day, now it's x to the third power. So does anybody want to take a shot at it? What do you think is going to happen or needs to happen to get the 3 to cancel out? I was hoping to see more than 3 hands. No? Okay. Caleb, what do you think? What am I going to do to get that 3 to cancel out and just be x? What would be the opposite of raising it to the third power? What have we been doing the whole lesson? Cube root. Yes, awesome. I knew more of you knew that, okay? I need to take the cubed root of both sides. So here's where we're going to get really specific. Did I just show the cubed root? No. Would that work? No. That's the square root. So without the little 3, you're going to lose points. You're not taking the square root. You're taking the cubed root, and you have to write the 3 there. So now x equals, now we could use our calculator, but we did already do the cubed root of 216. What was the cubed root of 216? 6. And it's 6 every time. All right, now let's address that positive negative thing. Remember when we did these with squares? It was always positive negative. But can my answer also be negative 6 with a cubed root? Yes. Is it true, though, negative 6 times negative 6 times negative 6 is positive 216? Is that true? No, because it's 3 negatives. It would be negative. So with cubed roots, my answer will not be positive negative. Only with square root, okay? All right, so that's important. What do you see here that's connected on the second one to our variable? What's connected? A negative and a fraction. So how in the world could I get my fraction to cancel out to 1? Not to 0, but to reduce it down to 1. How can I get a fraction to cancel down to 1? Now we're going way back, and please, 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 somebody know this besides Faith, besides one person. Faith, what do you think?
Do you have to like switch it?
Switch it meaning, what am I going to do? Flip that fraction and multiply. Multiply. And you have to multiply and include that negative. If there's a negative there, you have to multiply by the negative. You've got to take the negative with you to the other side. If you don't, the variable will be negative. You don't want that. Okay? So if I multiply one side by negative 4 over 1, do you agree that's going to reduce all this down? Yeah. To 1 n to the third, which is just n to the third. That was what I was hoping. But it's not n to the third equals 2. What do I have to do now to the other side? What do I have to multiply it by, guys? What did I multiply the left side by? Negative what? Come on. Negative 4. So I multiply the right side by negative 4. What's 2 times negative 4? No calculators. What's 2 times negative 4? Negative 8. Okay? So now I want you to finish it. Go ahead and finish this problem and write your answer. When you have it, raise your hand. I'm just going to glance at a few of them. How do I get rid of that exponent of 3? What do? Do we know the word for it? Do the cubed root. All right, so is this correct, the way that I showed it? No, this is the square root. So sadly, if you show this on your test, okay, that's not fully correct. It needs to be the cubed root. And then n equals negative 2. Negative 2 times negative 2 times negative 2 gives me that negative 8. So that's why it has to be negative 2. All right, last slide. 3b to the third equals 1029. And then you see the last problem. Go ahead and write those two down. Okay, so, hey, I heard that. Okay, so does anybody have a guess as to what I would do first on the first problem? I've got to solve for B. Jakari, what would I do? Very good. I see that multiplication is connected to my variable, so I must divide both sides by 3 first before I take cube root. All right, now all I'm left with is b to the third equals, what's 1029 divided by 3? 343. All right, I want you to finish it. Go ahead and finish solving this one. Okay, and we found that, don't forget the 3. Without the 3 there, that's a square root. B equals 7. Great job. All right, now let's look at this last problem. A couple things that are different. My variable's coming second after the equal sign. That's okay though. Because my variable's on the right side of the equation, I have to get everything, all my other numbers, to the left side of the equation. But I can't just dump them over there. I have to do some kind of operation to get them to the other side. All right, so I'm scanning the classroom to see who looks like they really know what my first step is going to be. Some of your faces are kind of funny right now. It's okay. All right, let's see. Jeremiah, do you think you know what's going to be my first step here? All right, I need to get m by itself. What would I do first? What would I do first? Any idea? Okay, you are going to do that at some point. Caleb, what do you think? You are correct. Okay, remember guys, when it's a two-step like this, we need to move what's not connected to the variable first. How do I get rid of positive 8? I subtract it, just like he just said. Subtract 8 to the other side and rewrite your equation. Now you have 25 equals negative 1/5 m to the third power. All right, now if you look back a couple problems ago, you should see how I can get rid of that negative fraction. I want you to try it and get to your answer and raise your hand when you have the answer. Okay, what do I do to both sides? What do I do to both sides? Guys, tell me, what do I do to both sides? I see it on your papers. Yes. Now, that cancels it down to 1. That doesn't cancel it down to 0. So now multiply the other side. So this is the mistake that I'm seeing. I'm seeing you guys do it on one side, but then you forget to do it on the other side. Stop talking. Pay attention. One more minute. That's it. Negative 125 equals m to the third. Here's the other common mistake that I'm seeing. This. What did I forget? The 3. You've got to have the 3 to show me you're taking cubed root. And then what's the cube root of negative 125? Negative 5 equals m, or m equals negative 5. And that's my answer, and that's everything you need to know for section 9.3.